This presentation is about maths accessibility, or perhaps more correctly, the lack of it. This is a very different OZeWAI environment, isn't it? And I must say that as a screen reader user, preparing material in video format does provide some challenges. So let's get into it. I'm mostly focusing on maths content in electronic format for blind people. However, as is usually the case, there are broader accessibility benefits than just for screen reader users, so I'm envisaging that quite a lot of what I say now will have relevance beyond screen reader users. I'm not going to discuss hard copy braille mathematical material because that's an entirely different animal. I will consider reading maths content and, importantly, writing it. If any of you in the audience are coders and looking for a challenge, as we go through this presentation, you will see a wonderful opportunity because there is the need for a fully accessible maths editor. Some of the resources that I'm going to discuss. Under formats, we'll look at normal text, MathML, LaTeX. I know it shouldn't really be pronounced LaTeX, but that'll work for now. Under tools, we'll look at MathType and MathPlayer, the Microsoft Office equation editor, thanks to my colleague Phil Mills from UTS who mentioned this to me only a week ago, LaTeXMathJax, Arrow, accessible R Markdown online writer, and Equatio. Basic arithmetic. Basic maths is easy to interpret if written in a text editor. Characters such as plus, minus, asterisk for times, slash for divide, and parentheses are all read perfectly well by the screen reader, assuming of course you have set your punctuation level appropriately. However, as complexity increases, ambiguity becomes a problem. Let's have a look at some basic maths.
5 plus 3 slash 2 equals 6.5. Left parent. 5 plus 3 right parent slash 2 equals 4.
All of that's completely easy to understand, but as I mentioned, as complexity increases, then the task of knowing what the creator of the equation meant becomes more difficult. What is MathML? It's an XML language for presenting mathematical content. Among other benefits, it can be screen reader accessible. Importantly, there is no ambiguity when reading a MathML equation. Writing complex equations by hand, and by hand I mean using a basic text editor, is not viable, and you'll see why in a moment. There's a great deal about the code I don't know, so please don't ask me tricky questions at the end. Let's have a look at some MathML.
Heading level 2, a simple example. X times 5 equals Y.
So that's pretty easy to understand. Now what I can do now is to press enter,
Math.
and the screen reader said math, and it's taken me into the equation, so now I can read the whole equation as I did before, or I can arrow left and right.
Start of math. Equals X equals Y. End of math.
So that one's pretty straightforward. I'll come to a more tricky one a little bit later. I'll drop out of the maths.
Heading level 3, the code looks like this.
The code, and as I said before, this is what makes it not viable to write the MathML content by hand if it is more than a very simple equation. We start off with less than math greater than, then we have less than mi greater than, which stands for math item, and then we have the x, and we close that off with a less than slash mi greater than. Less than mo greater than stands for math operator, and the operator in this case is the asterisk, and in the very best homes one shouldn't use the asterisk as the times symbol, but I've got away with it on this occasion. We close that off with less than /mo greater than. Less than mn greater than, that is math number, and the number is 5, and we close that off with less than /mn greater than. You'll be very pleased to know that I'm not going to go through the rest of the code. Let's jump down though to a more complex MathML equation. This is the standard deviation equation as shown by Wikipedia.
S equals the square root of the fraction with numerator 1 and denominator n minus 1. The sum from I equals 1 to n of open parent x sub I minus x bar close parent squared.
So you got all that? That's actually not the same way that I used to write the formula when I did stats at uni, but I'll accept their version as well. Now, if I go into this by pressing enter,
Math.
I can now press down arrow to zoom in.
Zoomed in all of the way. S.
And I can press right arrow.
Equals the square root of the fraction with numerator 1 and denominator.
I'll stop it there and zoom in further.
Inside square root. The fraction with in numerator. Zoomed in all of the way. In denominator n minus 1.
I won't torture you anymore with that, but it is possible to interrogate the equation very closely. And if, of course, the screen reader user was using a braille display, then that information would be presented very effectively on the braille display as well. MathType and MathPlayer. They are developed by Design Science. MathType is used to write mathematical equations. The output can be in a range of formats, including MathML and LaTeX. Unfortunately, it is completely inaccessible to screen reader users. The output is accessible, but the actual creation of the equations is not. It is purchased on a subscription basis, as seems to be the way with many products these days. MathPlayer is free. It makes maths accessible in Microsoft Word, so an equation written with MathType can then be read in Microsoft Word with a screen reader if MathPlayer is installed. So let's have a very quick look at MathPlayer and MathType.
MathType grouping. Insert equations grouping. Inline button insert inline equation left parent, Control plus Alt plus Q right parent, left dash numbered button insert left dash number equation left parent, Control plus Alt plus Shift plus Q right parent, open math input panel button insert handwritten inline equation left parent, Control plus Shift plus M right parent.
I'll leave it there. I thought it would be worth tabbing through some of the options, but as I mentioned, I can't do anything useful with them. It is also possible to use MathType as a standalone product, and that's MathPlayer as well. So you can have MathPlayer speak the equations. If you have a screen reader installed, that's really not necessary because the screen reader will do that. Potential of LaTeX. LaTeX is a typesetting system. It separates presentation from content by using codes. It's widely used in academia. Sophisticated documents, including maths, can be written. To use LaTeX, it is necessary to learn the code and/or to use a LaTeX editor. Many of the editors are not screen reader accessible. The Technik Center editor, which is made in Germany, is accessible to screen reader users and even has an accessibility mode. I don't think there's been any development over the last few years, but it's still a very useful tool. So let's have a look at some LaTeX. We'll let Tyler tell us about it.
/ begin left brace document right brace. / section left brace a LaTeX file including equations right brace.
That's a level 2 heading.
This is my humble attempt at writing a LaTeX file. / subsection left brace now for some maths.
And that's a level 3 heading.
Blank. / left bracket a -5 caret 2 equals 5 / right bracket.
and that is LaTeXMaths. Once the LaTeX has been written, it is normally output to a PDF file for the final document. The PDF that is created is not structured, and crucially, complex equations are inaccessible to screen reader users. LaTeXMathJax to the rescue. This little tool was developed by Peter Gibson at Chapman University. The address
http://math.chapman.edu/gibson/latexmathjax/index.html.
It uses regular expressions via JavaScript to convert the LaTeX codes into HTML. The conversion facilities are far from comprehensive, and even with my quite limited knowledge of both JavaScript and regular expressions, I was able to add some embellishments. MathJax, which is freely available on the internet, is used for converting the maths into MathML. Of course, you need to have internet access to use the tool. So what I'm going to show you now is the same material I showed you just now as LaTeX, but now it has been put through the LaTeX to MathJax process, and here we have.
This is my humble attempt at writing a LaTeX file. Heading level 3 now for some maths. A minus 5 squared equals 5.
So now we have a nice MathML equation, and the rest of the text is, of course, structured as it should be. Arrow, accessible R Markdown online writer. R Markdown is, as best I understand it, a development of the Markdown code, which is a nice tool for being able to write quite sophisticated documents without having to have vast amounts of knowledge. This tool was developed by Ju-Young Seo and Sean McCurry at Penn State University. I spoke to them last year about this because I was so excited about it, and I'm still excited about it because it really does do a lot of really nice things. The address, by the way,
http://www.arrowtool.com/.
It does a lot more than just producing mathematics. That's going to be our focus here, but it can be used for writing quite sophisticated documents, and it's has a lot of power available. My experience with the tool suggests that some LaTeX knowledge is helpful, particularly in the area of mathematics. So let's have a look at it. Let's have a bit of a read as to what they say about it.
It is designed to make the process of creating scientifically rigorous PDF, Word, and other types of documents easier for people with disabilities. Other ways of creating complex documents from text exist, such as LaTeX, but they are considerably more difficult to use.
And we'll leave it there for the moment. I won't go through all the facilities that they have on the page because you'll all go to sleep. I'm going to drop down though to the edit field, and this is material that they have put there as a sample. I could delete all this material and put in my own, but because I'm bone lazy, I'm going to stick with what they have done. So we have
Hash introduction.
You'll notice the hash sign in front of the word introduction. That means it's a level 1 heading.
Blank. This is the first paragraph dot blank. This is the second paragraph dot blank. Hash body.
And now we have a hash body, which means it's another level 1 heading.
Blank. Hash table example.
And now we have 2 hashes, which means it's a level 2 heading, and they show us a table. I'm going to zip down to the mathematics. Here we have the maths example.
Blank. $\some line left brace n equals 1 right brace caret left brace 10 right brace n caret $2.
You'll notice that it's somewhat similar to the LaTeX maths that I showed you earlier. Again, in the interest of time, I'm not going to go through all the options available. I'm going to jump straight down to the submit button, and because I've already pre-selected the HTML output, that's what will happen. I could have selected various other formats including Word and so forth. So now we have
Heading Level 1 Introduction. This is the first paragraph dot. This is the second paragraph dot. Heading Level 1 Body. Heading Level 2 Table Example.
and I'll jump down to the maths.
Math Example Heading Level 2. The sum from n equals 1 to 10 of n squared.
And that's the MathML that's been produced from that code that I showed you on the original page. And I could just download this HTML file to my computer if I wanted to do that. So a really nice facility. Equation editor, it's on the Insert tab of the ribbon in Microsoft Word. Equations can be written as LaTeX, but not, certainly at this stage, as MathML. What I've found though is that if I write an equation using the editor, I can copy that content and drop it into Arrow and finish up with a MathML equation, which is quite neat really. We'll have a quick look at it, and we'll go to the Insert tab of the ribbon. And here's our equation editor. There are several equations provided already. Let's choose this binomial. I've no idea what it means. What I have now,
Plus equals 0 minus.
if I use the application key, I can improve that somewhat. I'll do it quickly. I'm going to choose linear. Now we have a bit more detail.
Backslash left parent x plus a backslash right parent caret n equals backslash some line left brace k.
Still doesn't mean anything to me. But if I was to drop that into Arrow, I would at least have a MathML equation. So that's equation editor. It would be nice if Microsoft would develop it further, and possibly they will. Equatio, developed by TextHelp, and I guess that explains why it is primarily aimed at people who have visual reading difficulties for reasons other than vision loss. With further work, though, it could be a really useful tool for screen reader users. Equations can be output as a graphic in Word with alt text, and for a basic equation, the alt text is quite useful. Information can be copied as LaTeX, MathML, and quite a few others. So let's have a look at Equatio. As I've hinted already, it is not terribly screen reader accessible. I'm going to tab until I find the LaTeX editor. Here's the LaTeX editor. I'll use the equation editor. The problem with this equation editor for a screen reader user is that if I write, say, 5 times 5 equals 25, the screen reader echoed that back to me, but I can't go through the equation and edit it. I don't get the appropriate feedback for doing that. So what I'm now going to do is to tab until I find an unlabeled button. Here's the one. It's a sub-menu. So I'll copy the MathML. Now I'll go back to my Word document and I'll paste. So now I have
5 times 5 equals 25.
There we go. So we have an equation which in Word reads just like it would as MathML in an HTML page. I could have also copied that content into an HTML page. That of course requires requisite knowledge to do that, but the possibility is there. I'll close that so it doesn't destroy the rest of our video. Of course, it's a toolbar that just stays on the screen. So potentially a useful tool, but really needs to be worked on to make it compliant with W3C essentially. So where does all this leave us? Basic arithmetic can be read with plain text. Equations as graphics are not accessible. MathML has the potential to provide universally accessible math content. Creation tools, at best though, are not fully accessible, and at worst aren't accessible at all. Therefore, workarounds are needed to make the writing of math equations accessible. The ideal solution: a fully accessible math editor, so you coders out there. Equatio has potential. An accessible math type would also be a wonderful thing. Are there other options that I have missed? It's very possible, so if so, please let me know. In conclusion, can we do more to make maths more accessible? In the words of one famous person, yes we can. Thank you very much.